Hi all, myself Arjun and my teammates are Abdul Varis and Amog Sushilan. We are from NIT Calicut 4th year BTech students. Emerging technologies like drones, spy robots, and IoT devices face critical energy challenges due to the limited capacity of rechargeable batteries and the inability to recharge during long range operations. Solar energy, while renewable, is unreliable at night or in absence of light environments, creating significant gaps in power availability. With the increasing demand for sustainable and reliable energy solutions, there is a pressing need for innovative alternatives that can power these devices seamlessly and continuously. For this competition, we present our idea based on a metamaterial structure which can harvest energy from the microwave region of the electromagnetic spectrum. So in the first slide, we depict a comparison between the traditional batteries and RF energy harvesting source. Like you can see, recharging limitation, dependency, weight or size constraints, durability, operational cost, etc. are the major aspects by which we can compare the traditional batteries with our RF energy harvesting idea. So it is difficult to imagine a world where there is no smartphone, smartwatches, GPS, etc. Right? Basically, these electronic gadgets work in the frequency range of 1 to 3 gigahertz, which is the microwave frequency range. This makes them ambient RF sources, and the dependency it is independent of time, location, or environmental factors like uh, we don't care whether it is at night time or whether our required device should work in an indoor situation or an outdoor environment. And weight and size constraint in a later a part of this presentation we will be presenting a unit cell design from which you can see its dimension is very less compared to the traditional batteries. Durability compared to traditional batteries, its lifespan is very high. And operational cost for a metamaterial based RF energy harvesting structure, the operational cost is very less. Now coming to the basic definition of metamaterials. Metamaterials are artificially engineered structures which can alter the effective magnetic permeability and permittivity of a media. So in the picture which is in the right hand side, you can see how an electromagnetic radiation is uh, interacting with two media which are separated by an interface. And in the graph you can see the y-axis depicts the magnetic permittivity, whereas the x-axis depicts the electric permittivity. So towards the right hand side it is positive, and towards the left hand side you can see epsilon is negative. And similarly for mu also, upward direction it is permittivity, whereas going downwards you can see mu getting negative. Now coming to the point where how this RF energy harvesting with metamaterials work. So basically it has two parts. Like one is the RF signal receiving metamaterial harvester, and the other part is an AC to DC rectifier by which we can convert the AC current stored within the structure to DC and then store it for our later use. Like I mentioned before, you can see on the right hand side there is an example for a metamaterial surface. Like you can see it's a combination of so many unit cells. So like one structure in this meta surface is called its unit cell. So its unit cell dimensions are coming to be nearly 1.9 centimeter across 1.9 centimeter. So it is very small compared to traditional batteries. And the specialty of a metamaterial based design like this is that, like you can see, each of these unit cell will act as separate batteries. So it's an advantage, like if you cascade you can get enough voltage for an electronic gadget to get its power. Now, why we propose a metamaterial based structure and how it is different from other energy harvesting devices. So, like you can see on the right hand side, where we have simulated one structure using a computational software called CST. The incident radiation is mainly concentrated at one point. So from each unit cell you have to extract this stored energy from one region only, so by which you can reduce the complication in wiring and you can reduce the energy loss. Like for an efficient energy harvester, the two main points which it should satisfy are one is it should absorb maximum energy which is incident from the microwave source. The other one is it should able to transport the stored energy to the AC to DC converter without any significant loss. So we so our metamaterial based design is satisfying these two. Basically the concentrated energy when when an electromagnetic radiation from a microwave source is hitting is very high for this proposed metamaterial based design. You can see the red color area where the intensity of the electric field confinement is very high, and we are just transferring this stored energy to an AC to DC converter, by which we are able to produce a DC voltage. So on the left hand side you can see how these RF energy antennas, metamaterial based energy harvester, we are switching from RF energy usual RF energy antennas to metamaterial based energy harvester, and that's it. Now coming to the industries which we aim to transform by this discovery, one is the drone industry. So if we attach our meta surface to a drone, you can power it easily by sending some microwave signals. And spy robots, in some cases where you cannot use solar cells to power up your spy robots or any low power electronic gadgets and IoTs industry, etc. Now, as a summary and conclusion, our basic idea is to propose a metamaterial based energy harvester which could harvest energy from 1 to 3 gigahertz frequency range, and it could store maximum energy which is getting to it from the microwave power source, and it could transport energy without any significant loss to an AC to DC converter, so that we can store it and use it for later. So this is our idea, and that